All right, guys, this is Unit 4, Rational. Emphasize the first three letters, F-U-N, rational functions. This is going to be amazing stuff. So in this video, I want you to copy these examples down, and we're going to look at 4 examples so that when you come in on Friday, you hopefully have an idea of how to solve these. So let's get right after it. Woo! All right, guys, so in this example, what I want you to see real quick, notice there's no plus or minus sign. So what I want to do is to go straight across the numerator, straight across the denominator, and I want to combine those two fractions into one. So when we multiply everything, this is what we get. All right, so as you can see, as we go straight across, we multiply, we get 30x to the 5th, y to the 3rd, over 20xy to the 4th. And what I want to do now from two fractions into one is I want to see if anything can be reduced. And so I notice that I've got even numbers, 30 and 20. I've got x's top and bottom, y's top and bottom, so I can go through and cancel those things down, or actually not cancel, but I can simplify things down. So once I do that, I notice 30 and 20 can reduce to 3 over 2. Guys, all you got to do is cross out the zeros. That makes it pretty easy. And notice the 5 for the x up top, x to the 5th is bigger than x to the 1st on bottom, so the x's stay up top, and the y's are bigger on bottom, so 3 up top, take away 3 on bottom, leaves me with 1 y on the bottom. And notice that's as far as I can go, and we are finished with example 1. Guys, in example 2, the thing to note now is you got minus signs, or even if you had plus signs, the goal for this, what I told you on Wednesday, is if you can factor, this is not going to be that bad. But if you can't factor, it's going to be a long unit for you. So I see a trinomial up top, probably thinking I can factor that into 2 parentheses. More than likely, you're going to be able to. And the bottom looks like to me it would be dots. And you've seen this example, I don't know how many times you've seen it, but you've seen it a bunch. So we know that's also going to factor into 2 parentheses. So the top would factor into something like this, x minus 6, x plus 2. Awesome, it works out nice. And the bottom is a difference of 2 squares. And notice that when I factor, I end up with an x plus 2 up top and an x plus 2 on bottom. Those cancel. As long as something's up top and something's on the bottom, I can cancel those out. And what am I left with? X minus 6 up top and an x minus 2 on bottom. Guys, you don't need parentheses around these bottom 2. You can put it on there if you want, but do not cancel the x's out. Do not divide the negative 6 and negative 2, because that's all one term up top. That's all one term on bottom. So we are finished with example 2. This is amazing stuff. Guys, our third example now has 2 fractions. I've got plus, I've got minus signs. I've got signs all over the place. It's insane. So what I want to do is I don't want to just go straight across and multiply like we did with the first example. My goal is still, can I factor anything out? That's my goal. Can I factor anything? Well, I noticed the top left, don't forget, GCF is a factoring method. So I can take out of 2. That leaves me with x squared minus 5. I can't do anything on the bottom, so it's just x plus 1, so that's it. Top right, I can't do anything to, so it's just x plus 2. But the bottom right, once again, I can take out a GCF, and that leaves me with an x squared minus 5. So again, I don't want to multiply straight across because I got plus and minus signs. Can I factor? That is the question. And when I'm able to factor, does anything cancel? Well, notice I've got an x squared minus 5 top left. I've got an x squared minus 5 bottom right. As long as it's up top, somewhere up top, and if something is the same on the bottom, it doesn't matter where it's at. It doesn't have to necessarily be on top of each other. This is top left. This is bottom right. Those things cancel. So what do I have left? Well, I've got a 2 and an x plus 2. Okay, so I have a 2 times x plus 2. And I want to put it in parentheses because I'm multiplying 2 times this. Well, that's what I have up top. The bottom, what I have left is an x plus 1 and a 3. So I'm going to put that together, but I'm going to put the 3 first and then the x plus 1 second. What I don't want you to do is to multiply this out. It's real tempting to multiply this by 2, that by 3 on the bottom. You don't need to. It's not necessary. The reason for that is you would want to see, can I simplify these numbers, right? Well, 2 over 3 doesn't reduce, so I'm going to leave this as it is, and we are finished with example number 3 because nothing else cancels. You can't cancel these x's out right here because that x plus 2 and x plus 1, that's all one term. You are finished with example 3. So what we have left is this division problem, and something to note with this is, with this division, this problem here is all one term, so go ahead and put that over 1 should you want to. But wait a minute, you're dividing. When you're dividing by fractions, remember you're multiplying by the reciprocal. So what I want to do is I want to keep the stuff on the left how it is. So I'm going to rewrite it and put that over 1. I'm going to multiply, because we're dividing, we're going to multiply by the reciprocal. So what I do is I flip this second fraction, I flip it, and multiply by the reciprocal. Now, letters that you may have heard before, what I like to do is when I see a division, I'm going to keep this fraction the same. I'm going to change that to multiplication, and I'm going to flip this second fraction. So this is what I call keep, change, flip. KCF is what I call this when I see division. Now, so I'm going to do the same thing I did on the third example. My goal is, can I factor anything? And if you notice top left, I see a trinomial. I'm pretty sure this will factor to x plus 9 times x minus 3. I can't do anything with 1, so I'm just going to put that back, the 1 on the bottom. Matter of fact, I can't do anything on the top right. We don't need parentheses around the x plus 5. You can put it if you want to. It's not necessary, right now at least. The bottom, the only thing I can do is take out a GCF, and when I do that, I take out a 3x, and that leaves me with an x plus 9. And once again, I'm multiplying. I don't need to multiply all these things together. Just leave it in factored form. That's why I told you on Wednesday, we've got to be able to factor. Well, I notice I've got an x plus 9 up top, and I've got an x plus 9 on the bottom, so they cancel. So what do I have left up top? I've got these two binomials. So how do I write that? I'm just going to stick them side by side, x minus 3. Now I'm going to add parentheses because it is a binomial and I'm multiplying, right? So I want to keep them together like that. The only thing I have on the bottom, if you notice, the only thing that's left over is this 3x. Well, the 1 is there, but I'm not going to do anything with the 1. So I just have a 3x on the bottom. And again, we want to leave our answer in factored form. Do not multiply this back out. Keep it how it is, because it's possible when you get this far, you might be able to cancel with something that you have, but we can't. So we are finished with example 4. So I gave you 4 examples, trying to give you ones that you're going to see on Friday. So when you get your work on Friday, let's work together, get our stuff done. You don't need calculators for this stuff. You shouldn't need calculators for this stuff. But let's get our problems. Let's factor it down. Let's simplify what we can. Cancel anything that should be canceled, and get done with our work. Enjoy your weekend. Right now, I'm in Jekyll Island playing some soccer. Peace out.